Hello, advanced geometry students. It's Mr. Donaldson, and today I'm going to talk to you about section 8.5, which is the area and circumference of a circle. This should be really familiar, as you all have definitely talked about this stuff before in middle school. So the first thing we have here is, what's the definition of pi? You guys probably know the little symbol for pi. You can see it there. You probably have used it in a bunch of problems before. In fact, you probably celebrated Pi Day a couple days ago. I'm sure you all enjoyed delicious pie. But what the heck is pi? So I have a little Geometer Sketchpad sketch that can demonstrate to you all exactly what pi is. So the first thing I hear is I have a circle, and you'll notice the circle is the green part that goes around, of course, and then there's also a diameter drawn. Remember, a diameter is a chord that contains the center of the circle. So I can make this circle as big as I want, whatever. The first thing I'm going to do is I'm going to measure the circumference of the circle. Now, the circumference of the circle is the distance around. So if I were to start at this little point and walk all the way around this green circle, what is that linear distance? And the circumference of this circle right here is 30.27. You notice if I make the circle bigger, the circumference gets bigger. And of course, if I make it smaller, the circumference gets smaller. All right. Also, I'm going to measure the diameter. The length of that diameter is, right now it's 10 centimeters. Wow, that's pretty perfect, right? So you guys should notice by looking at these two numbers, 31.40 and 10 centimeters, that there's a special relationship there that will probably remind you of what you know is that decimal approximation of pi. So check it out. When I take that circumference and I divide it by the diameter, boom, I get this decimal approximation of 3.14159. As we all know, is the approximation of pi. And if I make the circle bigger, notice the circumference and the diameter both get bigger, but their ratio remains a constant 3.14159, etc. If I make the circle smaller, still the circumference and the diameter have changed. They've both gotten smaller, but the ratio stayed the same. So that is exactly what pi is by definition. It is the ratio of a circle's circumference to its diameter. So, in the next part it says pi is equal to. Well, pi equals c divided by d. A circle's circumference divided by its diameter. There's two decimal, or not two decimal, but there are two common approximations that we use for pi a lot of the times. And the first one is a decimal, and that's 3.14. Right? Now, you guys know, when you study pi in middle school, that it goes on forever. It's an irrational number. You probably maybe had competitions who can recite the most digits of pi and all this stuff. So it does go forever without pattern. It's an irrational number, but we're going to use 3.14 as an approximation. There's also a fraction approximation of 22/7. That's pretty close to pi. And what that means, because the definition of pi is the circumference divided by diameter, if you had a circle whose circumference was 22, the diameter would be really, really, really close to 7. All right? Not exact, because pi is irrational, but really, really close. All right? So we're going to use 3.14 most of the time. Most problems will either say to use the pi button in your calculator or to approximate with 3.14. All right, the circumference of a circle, if we just do some quick little manipulation with this formula, so you'll notice this formula here for pi. If we multiply both sides by d, we get c, or circumference by itself. So circumference is pi times the diameter, or because the diameter's length is equal to the length of 2 radii of a circle, 2 pi r is another common formula you would use for circumference. The circumference of a circle is a linear distance, so make sure you use linear units. So inches, or centimeters, or miles. Not square units. We reserve square units for measuring area, right? And then the last thing for these notes, this is a short lesson, is the area of a circle. And the area of a circle is, I have a little demonstration here to show you. I'm going to relate it to what we learned about parallelograms and rectangles. So check it out. I got a circle. We're going to unfold it there and look at all the area of the space inside of that circle's interior. And what you guys will notice is in this diagram, the circumference of the circle was 2 pi r. So when you lay that out flat, the length of that segment on the bottom, that red segment, is 2 pi r. And then we're unfolding that circle. We're making a bunch of tiny little sectors that are going to approximate little triangles. Now, take half of that. All right? Now, if I take that half on the left and I pair it with the part on the right, you make a solid parallelogram. All right? And remember, that bottom red segment in the beginning had a length of 2 pi r. So when I took half of it and created that parallelogram, then the length from this part on the left, where that black segment is, to the right, would just be 1 pi r. And then that black segment in the very beginning of this problem, it represented the radius of the circle. So this is a parallelogram whose base is pi r and whose height is r. And when you find the area of that parallelogram by doing base times height, pi r times r, you end up with the area of a circle is pi r squared. So again, you guys, this is just a quick visual to show you how we can represent the area of a circle using what we learned with the parallelogram. So the area of a circle is pi r squared. Just make sure you use square units. All right, we'll just look at a couple quick examples to make sure this all makes sense. Okay, so find the area and circumference of a circle with a diameter of 13 meters. All right, now the diameter is 13 meters, which means your teacher is a jerk, because in order to find the area, you need the radius. So the radius, and I'm going to make this deal with fractions, is 13 halves. So first we'll find the circumference because that's really easy. Circumference is pi times the diameter. Well, in this case, that's just 13 times pi. And we're going to write circumference in meters. Now, you guys, it is absolutely okay to leave our answer in terms of pi. In fact, most of the time, we're going to leave our answer in terms of pi. And that means don't give me an approximation, but leave the little pi symbol there. And that's absolutely appropriate because that's an exact answer. Now, for the area of the circle, we're going to do pi times the radius squared, which is pi times the radius is 13 halves squared. And when I evaluate this, I'm going to get pi over 1, write it as a fraction, times, when you square a fraction, you square the numerator to get 169, we square the denominator to get 4, and when we multiply straight across, we get 169 pi over 4 square meters. That is the area. Perfect. Don't be scared of fractions, it's fine. All right, this next example, we know the area of a circle is 144 square centimeters, but we want to know the circumference. I like to work backwards and think, okay, well, what do I want to find? I want to find the circumference, and in order to find the circumference, I need to know the diameter. So I'm going to use the area of the circle to find the diameter. The formula for the area of a circle is pi r squared. We know the area is 144 pi. We're going to use that to solve for the radius, because once I know the radius of the circle, I can simply double it to get the diameter. So the first thing I'll do is I will divide both sides by pi. And I get 144 is equal to r squared. Then when I square root both sides, I get that r is equal to plus or minus 12. Remember, when you introduce a square root to solve for a quadratic, you got to account for the positive or negative. But because the radius is a distance, you can't have a negative distance. So the only value that we're going to use is the positive, so the radius is 12. Well, if the radius is 12, that means the diameter is 24. So the circumference of this circle would be 24 pi centimeters. All right, that's it. That is circumference and area. Pretty straightforward. Just know the formulas, and you plug in, and you're good to go. All right, have a good one.